Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about transformation of a graph. In that, we discuss about stretches and compression. Here, stretch. Stretch of the graph is defined as y equal b into f of x, where b is greater than 0 and y equal f of x over q, where q is greater than 0. This is called stretch. It is also called dilation. Multiplying the x by a number between 0 and 1 will make the graph wider or stretched horizontally. For example, multiplying the input by 2 would produce the graph that is half as wide. But multiplying the input by 0.5 results in a graph that is twice as wide or stretched horizontally. Look at this. Here, this block diagram. Vertical, suppose y equal to a f of x means it's vertical stretch. That means a is multiplied with the function outside this vertical stretch, scale factor a. Here, horizontal stretch is if a, the factor, is multiplied inside the function, then it's called a horizontal stretch. If it is outside, it's a vertical stretch. If it is inside, it's a horizontal stretch. Here the scale factor is 1 over a. Now further we'll discuss about stretches and compression of a graph. Stretches of a graph first. F of x equal to x square. Then a into f of x equal to a into x square. A is multiplied outside the function. This tells us that we need to multiply each of the y coordinate on the graph by a in order to stretch original graphs. It's a vertical stretch. That means the function is multiplied with the factor, positive factor a outside, then it's called vertical stretch. For example, f of x equal to x square, then 3f of x equal to 3x square. 3 is multiplied outside the function. Look at here, at some coordinates, we know that f of x equal to x square is a parabolic curve, goes through the point -2, 4, -1, 1, 0, 0. These are the points on the parental graph. If you multiply with 3 with f of x, that is 3f of x equal to 3x square, we need to multiply each of the y coordinates by 3 to determine the stretch position of the graph. That means the original point is -2, 4, become -2, the 4 is multiplied by 3, that is y coordinate 12. -1 and 1 becomes -1 and 3, like all other points. Look at here. Here, this purple color graph is parent graph, that is f of x equal to x square. Suppose if you apply after stretching the points this, then we can draw a graph like a given green graph, which is equal to 3f of x. That means y coordinate is multiplied each by 3, factor 3, that is 3f of x equal to 3x square. Now this is the parental graph is this one, and it's go inside. This is a compression. Compression means stretched down in inside. That means what? It is become reduced. Now, compression of graph. If f of x equal to x square, if f of ax, that is x a is the factor is multiplied inside the function, this function become ax square, which means this tells us that we need to divide each of the x coordinates on the graph by a in order to compress the original graph. For example, f of x equal to x square, then f of 2x can be written as 2x whole square. Looking at the same coordinate again, that is f of 2x equal to 2x square, we need to divide each of the x coordinates by 2 to determine the compressed position of the graph. Look at here. Here, the functions, the coordinate of the original parental function is minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 2, 4. It becomes here minus 2 is multiplied with divided with 2 becomes minus 2 become minus 1 and y coordinate as it is. That means here the factor is multiplied inside, then it must be x must be divided by the factor. Minus 1 divided by 2 is minus 0.500, like that. Here, look at here, this parental graph is a purple graph. This is here. Here it is compressed with 2 factor 2, that is f of 2x equal to 2x square. That y coordinate is divided by that factor 2 here. So here parental graph is here and stretched, that is compressed graph is here, that is green graph. Look at here some examples. The diagram below shows the graph of y equal to cos x. Here y equal to cos x is a parental graph with the 0 to 180 degrees. Stretch the graph of y equal to 2 cos x means here the factor 2 is multiplied with outside the function, marking the new coordinates of this one. First, original coordinate is a point A is 0, 1, here 0 degree 1 and 90 degree 0 and here 180 degree minus 1. Suppose if you multiply that 2 outside the graph, this graph become, look at here, multiplied with the y coordinate by 2 means what? A dash becomes 0 and multiplied 1 into 2 is 2. Here multiplied by y coordinate is 0, 0. So here it is the same point. Here 180 degrees minus 1. 180 degrees as it is and minus 1 is means multiplied with 2 becomes minus 2. So it is a stretched graph. The original graph is a black color and stretched graph is a green color. That means we are multiplying the factor, positive factor, that is 2 with outside the function. It stretched vertically. Next diagram, look at here. The diagram below shows the graph of y equal to f of x and y equal to g of x. Two graphs together given in same diagram in same axis. Then describe the single transformation that maps the graph y equal to f of x onto g of x. That means you have to find what happened if the function y equal to f of x onto y equal to g of x. Here the original function is a black color here. This original function is y equal to f of x and then g of x is the green color. What happened? That look at here, the key points x coordinates have been multiplied by 3. Divided by 3. Then horizontal stretch happen. Horizontal stretch, that is scale factor with 1 by 3. It's called a horizontal stretch. Also, you can call as compression with factor 3. That means 90 divided by 3 is 30 and 180 divided by 3 is 60. Then this graph becomes, that is the black color graph becomes compressed. That is called, it is also stretched with factor of 1 over 3. So far we discussed about some transformation of graph of stretches, that is called dilation and compression. We have done. Please subscribe our YouTube channel.